My dear students, now we are on to the next lesson, that how we could calculate the impedance of a circuit. And first of all, here is a waveform. That's a sinusoidal waveform. It is pretty much known to you. We can write it down like this: Vt is equal to Vm sine omega t, and there's a t and there's a Vt, and we can find out this also. If we just think about a series circuit of RL circuit, and that's the Vt signal, that's the input signal, and the reactance of RL is XL, and the unit of L will be the Henry, and the unit of XL, the reactance of inductance, will be ohms, and the resistance will be also ohms. And if we want to find out the Z, the impedance of this RL circuit, we will get R plus J XL. Okay, and if the resistance in this equation is 3 and inductance is 4, so we can easily write down 3 plus J4 plus J4 ohms. Okay, and you can find it out in the RL circuit. There are 3 type of circuits we can discuss in AC circuitry. That's gonna be like this: the RL, the RC, and the RLC. There are 3 type of circuits. First is RL, I have shown it before. Second is RC, and last of all is RLC circuits. Okay, both the previous circuit is series circuits. They can be series, they can be parallel. We have to find out the impedance, how we could calculate the impedance. So RC circuit, you can also find out by this R, and that is the resistance, that is the capacitance, resistance R, capacitance is C, but the reactance of capacitance is XC. So the input voltage Vt, as usual. We can find out the impedance of RC circuit. It is R minus JXC. If there is another part, if we add this here, this circuit, it is inductor. If we add an inductor here, so it will become an RLC circuit, and the impedance will be XL. And always you have to keep on your mind, impedance, the unit of impedance is also ohms. And in RLC circuit you can write down Z, the impedance, total impedance will be R plus J X L minus J X C, and by taking the common R plus, you can take the common J here, and that is XL minus XC, XL minus XC, XL L minus XC. Okay, it's not very clear. I have to make it clear. You can see that X L minus X C. Okay. That is the impedance calculation, and all the impedance will be calculated as ohms. Now, my dear students, if you have some another problems which doesn't consist the number of the value of XL and XC in some mathematics, there may be no XL and XC in the mathematics. How can you calculate XL and XC from it? In that case, you have to know this equation, XL equal to J omega L. First of all, you have to find out J omega L ohms. Then you can find the reactance of inductor, and reactance of capacitor is XC, that is 1 by J omega C. That is 1 by 1 by J omega C. And for this equation, how you could really find out this? In that kind of circuitry, your omega will be given onto the Vt part. If it is a Vt, that is Vm is 3 sine 40. Okay, in this kind of math, 4 will be your omega, and you can put this omega here and find out the reactance of inductor and capacitor easily. In some mathematics, there will be L in Henry, that is 3 Henry or 3 millihenry. Capacitance will be in farad because the unit of capacitance are in farad. So 4 farad, 2 farad, thus this kind of things you can easily find out by giving the value to these equations and finding the reactance out of it. Okay, so that is the end of the lecture of impedance calculation. I hope you will understand and use it your mathematical calculations while you solve the AC circuitry. You will keep on your mind this circuitry, these calculations very quietly, and understand this and use this on your mathematics to solve the mathematical equations and also find out the voltage and current of the circuit and all the other theorems. That is the basic of finding the impedance. Thank you very much for this. Next lecture we will learn the series and parallel, how to calculate series and parallel in impedance. Thank you very much for being with me.